Here is our line. The presentation is divided into the 4 parts. The first is the introduction and overview the competitions at IEEE WCCI 2020. Then, I'm going to introduce the structures of ANFIS-based patch learning mechanism. Thirdly, we will present the experimental results. And finally is our conclusion. So the first, I would like to talk about the competition data. We adopt Google AlphaGo Master 60 games to be the data set. Among them, the game 1 to game 40 are used as the training data, and the game 41 to game 60 are used as the testing data. This diagram shows the two-stage system structure for robotic Game over Go application. The stage 1 presents the human and smart machine co-learning on Game over Go, and the stage 2 is our fuzzy machine learning mechanism and interacts with robot KBL. Okay, let's move on to the next part. In this part, we will show the structures of patch learning-based AI FML agents for Game over Go dataset. We adopt the patch learning-based AI FML agents with 3 patches mechanism, including the patch 1, denotes the move 1 to move 20. Patch 2 denotes the move 21 to move 40. Patch 3 denotes the move 41 to move 90. The last one is global model, denotes the move 91 to final move. Here are our fuzzy variables. We have 6 variables for fuzzy inputs. The top table is the original data, and you can see that the DBSN and the DWSN denotes the numbers of simulations predicted by the dark forest. DBWR and DWWR denotes the win rate predicted by the dark forest. And the DBTMR, DWTMR denote the top move rate predicted by the dark forest. Additionally, we also have one output, which is EBWR, denotes the break win rate predicted by the proposed approach. This is our 5-layer fuzzy inference mechanisms, including the fuzzification layer, rule layer, normalized layer, inference layer, and the defuzzification layer. In these computations, we implement ANFIS using PyTorch framework. PyTorch is an open-source deep learning platform for Python. And the next is our fuzzy set of the fuzzy variables. Each fuzzy variable has 64 initial Gaussian fuzzy sets with linguistic terms. This is before learning, and here is after learning fuzzy set. This page shows a part of before learning fuzzy markup language. The right side is rule-based, and the left side is logic-based. The fuzzy markup language is based on extensible markup language. The black color is XML-based language. The red color is input fuzzy variable. The blue color is linguistic term. The green color is output fuzzy variable. And the next is our experimental results. This page shows the regression analysis for Game 39 and Game 58. The experimental results show that the AI FML agents with the patch learning mechanism can improve the performance of regressions for robotic gain-of-goal applications. Everyone can see the figure A. This is a before learning model to predict the win rate. The figure B shows after 2000 epochs learning with the amphis. Figure C shows the patch learning with 3 patches by 1000 epochs machine learning. Finally is our conclusion. In these competitions, we propose an AI FML agent with patch learning mechanism for robotic gain-of-goal applications. The mean score error has a decreasing tendency when the patch learning mechanisms in experimental 2. The AI FML agents can communicate with the IoT device or robots by publish the inference results of the Go application. And the next part, we will demonstrations robotic gain-of-goal real-world application. Thank you for listening.